Hi, everybody. Good evening. My name is Max. I'm data scientist at Bolt. So my initial background is in telecommunication engineering and statistical signal processing, but now I'm solving machine learning tasks related to logistics, and we're helping to grow Bolt in one of the biggest players in the world. And the topic of my presentation today is what they don't teach you in machine learning courses. So it's a bit of kind of exciting title. So let's see what's behind that. And for those of you who don't know Bolt, we're one of the biggest and we have the fastest growing ride-hailing company in the world. And we are sharing the position of #1 player in Europe and Africa. And we are planning to build the biggest tech company in Europe at least. And we are really glad to compete for that title with our own TransferWise here. So that's pretty cool. Anywho, the first part of my talk will focus on what they don't teach you in machine learning courses, actually. And second part is about data science access on Bolt. I will talk a bit later about what's at it. But to start, let me ask you a question. How many of you have actually deployed machine learning in live, in production? So which means like it's running somewhere outside of your local machine and impacting your customers. So can you raise a hand? So about 20–30%, quite nice. Then second question, how many of you can actually draw or paint? Much less people, really? I didn't expect that. Wow, that's quite exciting. Anywho, very brief intro into how we can become a great painter. So if you want to draw an oil, you will start with 2 circles, and then the second step is like draw the rest of the oils. It's very, very, very easy actually to become a great painter. And now, if you think about what people actually, what skills they learn during when we go to Coursera or Udemy or like whenever they try to pick up like machine learning skills, or for example, if you have some course in university, most of these courses are actually focusing one part, and that part is actually the model and how to build the model, how the different models are different, how to prepare data for the models, a bit about feature engineering maybe, but mostly on the properties of the model. You will probably get an assignment on implement the gradient descent yourself, although like they're like much more efficient implementations. But I mean, you're basically focusing on this. And if we continue with our metaphor of like drawing an oil with 2 circles, it's actually like if you want to deploy ML product, if you want to make impact from your company, and you want to start somewhere, you're basically starting from your machine learning model. So you train the model, it's quite nice, it's all good. However, the story is that the model itself is like really, really, really small part of what is necessary to build in order for your model to make an impact on your customers. So it's like really, really, really tiny piece here. So if you're focusing on this, it's basically there's still many pieces to solve. And if you look at what people usually, what sort of scales they pick up during mocks or school, it's rarely something from here, so like rarely on the courses you will hear like, so how to actually implement the monitoring, how you should actually monitor the performance of your model in life, how do you actually know that your model is making the exact prediction that you say on your test set in reality. It's like not very trivial task though. As well as like you will spend like a lot of time figuring out like what's the best serving infrastructure, like how do you actually serve your model, like depending on what sort of application you're running, maybe it's like you need to have like really low latency, so where do you get this data? A lot of questions that you need to answer. So when you start like working in industry, there are like a lot of things for you to discover. So and it's actually not kind of unique for example for our company or like for small companies, for example. It's also the same as we saw from informal survey in Google. So the guys there asked new people in their teams, like who were dealing with data science and with machine learning, like, so what's your like expectation, like when starting with machine learning projects, like how much of the time you will spend on certain tasks? And as you see, like people spending like they expect to spend 60–70% on optimizing models, and reality is much more different, right? I mean, in reality, like the part where you optimize models, like really small part, you will probably spend like tons of time of collecting data. tinkering with this, like removing outliers, cleaning it up, understanding like, okay, now I have data for training models. Like if I want to have this same kind of data in the same way when I'm serving my model, what to do then? I mean, so it's completely different. So you'll spend a lot of time on integration and developing infra. So it's like completely different view. So it's like this mismatch of like expectation and reality when you enter the field. And if I have to give a suggestion for people starting in the field on how to like bridge the gap, like most of the people, like how they start is like, okay, I want to get in the field. Probably, I mean, maybe there is like degree program in my university. Okay, cool. If not, then I will go to Coursera, Udemy, whatever. Then the next step, okay, maybe Kaggle. Kaggle is a good place, right? I mean, like the best machine learners competing, like, so like I will learn like very good skills there. Yeah, not very much. So like the skills you're learning in Kaggle is mostly relating to this, how to optimize the last like percentage of your models, like 0.0000001, right? And it's usually like often like just by chance you will manage to find like the best like parameters for your model, or like you combine it like 20 models together, it crunches like a week, and then you get like model which is a tiny bit better than for your competitors. So a lot of this is actually like a pure chance. But feature engineering, you might learn like quite a good tips from Kaggle, because like often spending a lot of time on feature engineering might win a competition, so that's good. But you won't hear anything about integration, development infra. Most of the data sets are collected for you. Like you don't know anything about that. So you're coming to work like, okay, where is my clean data set? Give me clean data set. I will now train all the thing I can. No, that's not true. So if I give a suggestion for people starting in the field, as soon, like, I mean, don't get me wrong, like all this machine learning courses are like really, really useful, and like you need this stuff to start with. I mean, obviously you can't like start in the field if you don't know how to train the model. But really important is like take some project, like some idea that like you want like what you're passionate about, and try to build a whole pipeline. Try to scrape the data somewhere from the internet. Train the model, serve it somewhere outside of your local machine, right? Do like the whole path. It will give you like so much more, even if you like win the first prize on Kaggle probably. Like in terms of reality, in terms of experience you get on how to deploy models, like I think it's maybe one of the best places to start. And the same kind of problem as we face here, like when new people come into the field and they struggle with like what to start with, it's kind of very similar when you start with your data science function inside your organization. It's kind of the same trouble. So there were probably engineers before that, they're building something and they're like business understanding what's going on. And then at some point, like your company is like big enough and it's like, data science. I need to have a data science team inside like my organization. And then it's like other level of complexity. Okay, what's data science? What do I need data science for? Like where to place this? Like data science is like engineering, it's like business. Like what's data science? So our tech industry like more or less have learned how to make engineers and business work together. So we have like this magic person product manager, takes input from business, digests it, spits it out like to engineers, like now you have this, engineers say, okay, 2 days for that, 5 days for that, okay, like 10 days, product managers multiplies it by 2, and then like you kind of get like how the things works. Now, if you think like the same scheme on how it will work on data scientists, like product managers comes to data science, so like how much time you will estimate like in project stage, I don't know, I haven't seen the data, so like how I would expect anything. Like, okay, but how it will work? I have no clue. I mean, like I cannot say like how accurate my model will be. I mean, like for all I know, it will be rubbish. So it's very, very like different way of thinking when we start dealing with data science projects as well, like for business and for product managers. We have to think like data science actually is a research project. So we are dealing, yeah, sure, go ahead.
How far away the machine learning contest models from the real life models?
You mean like this? You mean the stuff that wins you Kaggle? How far is away from?
How far is away from the real life?
Let's say the types of the models. So, for example.
In the graphs which you have just shown us with the expectations in the real life. So So it's expectations, the real life, and if we add the additional graph for the contests, how far it will be from the real life?
It will depend on the contest, right? I mean, like if we just look at here, so you take for the Kaggle competition, you don't have to spend time on that. You don't have to spend time on that. Developing infra, depending on like how big of a model you want to train, right? So probably not much time here. So you're spending like, I don't know, 90% on that, right? Yeah, even like more inflated towards machine learning, I would say. Okay. Yeah, feel free to interrupt me if you like have like idea or like thoughts. So that's like it's two-way street. It's a conversation. Yeah. So data science is mostly like research project, and we should like treat it as such, which means like it's very hard to expect something. So if you're not sure that you have resources to keep like data science team around, and if after the first failure you say like, okay, I actually don't have money to sustain it, maybe it's better to start with like data analysts and not to bring like data scientists on board right away. Also, one interesting thought I actually discovered about this graph, I don't know, hour ago when I look at this, it's different dynamics that happens between kind of stakeholders and data scientists as opposing to engineers and business. Oh yeah, engineers and business. If you, I don't have like arrows here, but if you think about how like engineers and business like interact, it's mostly like all the requirements coming like from business and like just feeds into engineers, right? I mean, so rarely like something can come back. Like back comes something like I need more engineers, I need more time, I need more resource, basically, but nothing regarding like what's the scope of the task probably. I mean, okay, technical stuff, but it's like engineers are solving themselves, right? If you think about like interaction between business and research, right? I mean, like so maybe like first questions will come from business, but you as a data scientist or like data science team or data analyst team, they will be working with data. At some point, they will understand much more about business than the business holders. So it's like our kind of goal to start feeding this data back to decision makers and not just like answering the question they have. So I mean, how much I need to invest to grow like 10%? I mean, okay, you can answer this question, but you can provide much more valuable insights than that. So it's like has to be like two-way street, always like communicating. And also, as data scientists, if you want to like make an impact, so talking about building something real and impacting on customers, you have to like communicate with software engineers, right? I mean, like they're providing data, they're providing pipelines, they're providing server infrastructure usually. So will it be like software engineers, data engineers, people who manage your data warehouse, doesn't matter. I mean, have to be like technical as well. So if you think about this thing that we're discussing right now, it was apparent for us when we started our team, which was like 1.5 years ago, that we have like two big problems. Like, again, not problems, challenges, right? It's like actually building a team, so finding all those people who are capable of delivering the impact for the company, so actually giving back the company, like repaying the trust, as well as finding the place for data science team, data science function inside the organization. So, and that's actually, I'm not sure like which one is harder, but I know for sure like nothing like that they teach you in machine learning courses. Yeah, go ahead.
Was it a problem-driven or a quasi-driven?
To start data science team?
Yes.
Problem-driven for sure. I mean, absolutely. I will talk, I think, maybe in a couple of slides what sort of problems we are solving. You'll see like it's not a buzzword for us. For us, it's like a necessity. I mean, if you either start solving those tasks or you die. Yeah, just to give you a bit of context about our team, we started 3-4 people. Now we're about 30. So like I'm including data analysts, data engineers, data scientists. So quite a big team. We have very diverse background in our team now, talking about only data scientists, so people with experience in computer science, AI, statistics, econometrics, signal processing, sociology, like everything basically. And in terms of challenges that we face, like usually people like start wondering like, okay, I just open a phone and then order a taxi, like why do I need like data science for? But if you think like there are like vast space of challenges that you need to solve. So for example, maps, how to position yourself on the map, right? I mean, for us, it's like very simple. I take a phone and I see like Google tells me, right? It's completely different in Africa. You don't have infrastructure like like data infrastructure, let's say mobile data infrastructure, right? People don't have connections to the phone. GPS signal, it's sometimes it can be non-existent because people are using like really the cheapest phone they can get their hands on. So the signal is like really bad. So actually, problem of positioning yourself like on the street is like really important problem to solve there. So we're talking about geospatial modeling, like dispatching, like which car we should send to which customer in order to optimize our system. Obviously, pricing and financial decisions, demand-supply balancing. Even outside of kind of machine learning models, we're talking about more a classical operations research problem that we need to solve. Simulator is the cool stuff. Simulator is basically how we can play out different scenarios in our different cities in order for us to understand what's the impact of our decision will be, and not going to start A/B testing first, because we can do like simulating much faster than coming and measuring things in real life. So we will understand at least at some point like what sort of like plus or minus like decision we'll make. And obviously to make our data scientists and engineers to work much more efficiently, we need to build like all this machine learning platform around that. So it's like, maybe that's like kind of like new buzzword in some like data science. Everybody building ML platform like Netflix. Okay, Uber was there Michelangelo a long time ago. But it's also, that's again, that's necessity. I mean, say you have 10 data scientists, right? I mean, so, but you have a lot of tasks. So what you can do, you can hire 10 more, when you can make like 10 data science more efficient. So it's like kind of trade-off, like which path you would take. So, and when we started considering this, that we have like people with diverse backgrounds, somebody coming like from academia, somebody like fresh graduates, somebody with a lot of experience, solving different tasks. Then we started like seeing that we're facing kind of very similar problems in similar projects. So we thought like, okay, probably we should like put some like playing rules or like guidelines. So like that's kind of good practice. That maybe like not so good. You should follow this, maybe not. And that's actually how our data science excellence was born. So data science excellence is a kind of like set of like not rules but guidelines to say like what we think is like good mindset when you start the project. What should like focus on? So by no means those rules are kind of 100% you should follow them. It's mostly like guidelines, and there are always exceptions. So if you see like there's like better way, you should do it like that. Very important, all this focus directly on impact. So it's always like that impact driven. So whatever we do, our main goal is actually to make the impact on business, make impact on our customers. So currently, as we start, we kind of chose a direction of starting optimizing slowly and kind of short to mid-term, so not doing like very long research projects, just to be able kind of like sustain the company growth. And then when you have like more capability of doing like this long-term R&D and spending like years on playing with one projects, then it makes sense. But first we need to catch up with Uber, Lyft and others. Then we can spend more time on kind of like long shot and like really exciting things like reinforcement learning, transfer learning, or all that thing. But first like really dealing with applied machine learning. So I'm just covering like a couple of topics inside data science excellence. More of them can be found in a blog post regarding the matter. But okay, let's start and cover a couple of those. So problem statement. All the good projects should start with problem statements. So let's say you have an idea, or like your business manager or like whoever provides you with idea, you should work on that. Just stop for a second, don't run and get data right away. Start modeling, saying like, okay, what sort of accuracy or ROC I can get of this. Think a bit. Think like, what is actually the problem you're trying to solve? Like, what was the impact of the model that you're going to deliver, or like how you would deliver like the impact with the model like in the end. For example, I have a good example a couple of weeks ago. We were asked to kind of make a prediction on what sort of return of investment we would expect in each city, that like if we will place that amount of money and say on certain initiatives for riders and drivers. And we said like, okay, 7 days forecasting, sounds good, let's do this. So we created some sort of prototype, like presented it back to the stakeholder. He looked like, cool, okay, pretty precise, cool. Tell me what's the return of investment going to be in 30 days? It's like, but this model forecasts for 7 days. I mean, that's what we agreed upon. It's like, really? I thought it can solve everything. So it's also like this part of like educating your stakeholders, like what sort of thing they can expect from machine learning. So it's really, people should know machine learning is not magic. It can't solve all your problems. So it's like very specific tool, and you should use it wisely. So spending some time on like querying, yeah.
Just in practice at Bolt, and I'd be interested for other folks. What percentage of these like data science initiative ideas are coming from somebody with a title in engineering or data science or research versus somebody in business, product, sales, that side?
I would say it's roughly 50-50. So there isn't like varying, like it's not imbalanced. So it's not like business owners like this, or like only data science come, we can do this or this. It's like actually I would really like give big kudos to our like top guys. They're like really smart people. It took like them some time to like learn like how to use machine learning. But now, for example, we come to the meeting and then like one of the chief growth manager, let's say, starts asking. So, say if our previous day's prediction is like real results are low, how it will impact your model? Or like at some meeting say like, have you considered this feature? And starts like participating in feature engineering and say like, yeah, dude, I haven't considered this feature. It's pretty cool.
So how do you get these people into it? Because where I've been in the past, I'd say that it was much more 90% smart people who have some business sense in the data science and research side, and maybe 10% from the actual business side. So how did you get people in, and then is it like one or two people from that side who have lots of good asks, or is it actually spread wide? And how did you achieve
it's spread wide. I will talk about it a bit later, but I can answer right away. So it's just educating, talking to people. So we have done several sessions for our product managers, like sort of under the hood, how we're solving problems, and we explain like, it's okay, that was the end result, but how we actually got there. So like speaking to people, educating them, actually showing the value of what you do, then you start buying in. But it's like I don't know like how else you would start solving this. So it's actually really hard, and I think half of the success that we have is just because like we have like very smart guys on top who can appreciate that, and who like had time to participate in all those meetings and then participate really actively, starting asking like really deep questions in terms like, so what is the definition of like this feature that you put there? Like, so if I do this, like what happens there? Like finding the problems in our models, like troubleshooting with us. So I mean, really like up to the top guys, up to the markets basically. So I mean, yeah, maybe we just got lucky. Also, don't know. Anyway, after the problem statement, really important part, like a lot of people miss, like literature review and existing solutions. Maybe not relevant for everybody, but if you want to move quickly, if you want to be efficient, like with the startups, like there are a lot of good libraries, a lot of good tools around. So just get them, use them. I mean, you don't have to reinvent the wheel all the time. I mean, sometimes it's cool, but if you just focus on impact, just take the tools, use them, like proceed. And this is an iterative process, so always come back and validate. It doesn't make sense. Like, okay, I have now my problem statement. I will lock myself in the basement for 2 months and came out with the model. It's like each week, like come and see like if this is still relevant. Maybe business is changing that fast that it doesn't make sense to. Doesn't shoot. It doesn't make sense to work on this, or we have like to change the statement. So it's very important like to move fast and like in an iterative way. So timeboxing. Sure, many of you are familiar with machine learning. Is like you can spend forever like getting more data, cleaning more data, creating more features, tuning the model. We talked about that already, like in context of Kaggle. So the question is like, is it worth it? So we spent a week on the model. Okay, it shows some sort of accuracy. I don't know, 80%. Should you speak 2 more weeks to get it to 85, or should you like consider next model, next challenge, which will solve another business important tasks? And different from Kaggle, like for the companies, it's usually like the impact the model creates is like based on like the monetary value or like what sort of experience your customer gets. So you should like always optimize on this and not like, can I get this model as precise as I can, basically. So always think like, what sort of effort gets you like the most results? In our case, like we have so many unsolved problems yet. So it's basically solve in 80% cases, move on. Tooling. Yeah, I think it's relevant for the teams, especially like if you're a data scientist, like working alone, it's maybe less relevant. You can choose your own tools, like not very important, like to share the stuff. For us, it's like very important. fastest way to move forward together as a team inside Bolt. So if we see like that there isn't like a tool available in the market, building ourselves, if we can buy something which makes it quicker, and in terms of like our time, data science time, we just buy it. Obviously, we have set of own data science libraries, so we're working on kind of very similar problems. So let's say you're building or you created a tool which compares two heat maps, right? Basically understanding like how the spatial data is different. Probably with high probability, like you parallel over the table, like needs like exactly the same stuff. So it makes sense to spend like a couple of days like polishing the function and putting this our internal library. So other guy, then we can start using it like directly. So okay, you lost time, he won time, and it starts accumulating, right? Like in a year, you're like getting like a lot of return on investment just to spend on time. So it's very, very important for us, like contributing back to our own libraries. Code review. Yeah, for those of you who are in software engineering, I think that's basic hygiene. You know this, you don't need to cover this. For people who are starting in data science, it's maybe often not kind of very obvious, like what's my code review? I train the model, I see my accuracy, right? I mean, it works, it's fine. Yep, not really. When you start seeing, like, when you start putting things to life, you can see like very, 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 very tricky situation with stuff don't work, and then you understand, okay, my time zone conversion actually was a bit wrong. So I'm actually forecasting for like different period in time. But how is the code that you're working in data science project is different from the actual code that software engineers are working? By two things, actually. That it's not only the code, but we have also data and we have our assumptions, right? So I mean, like, very underlying part of like what we deliver is data. And together with data, we make some assumption about the real world that we try to model. So let's say if I have like a code for my project, I will show it to engineer. He probably can tell like million of reasons like where I have bugs and everything, but he probably can't tell me anything about like my assumption about data. So he can ask me a question. So what's your definition of demand here, right? Or like, why do you choose to impute your missing values with averages and not median? I mean, it doesn't like the engineers usually don't think like in such terms. So it's either like your data scientist who can also like review your code in terms of like software engineering composition, or you're like kind of doing like separate steps of evaluating your like software engineering part of the project as well, like data assumptions, like modeling assumptions. So like a bit different. Also helps to facilitate the knowledge sharing inside the teams. So as you're working on different projects, then basically people get to learn like what other people are working on. So also pretty cool. Oh, visibility and communication. That's the hardest part. And I don't think like anybody solved that. Yeah.
Actually, I had a question regarding code review.
Yeah.
Do you review other people's Python notebooks within data science team? Like, do you ignore them?
We have reviewed. So it's depending on like. So obviously we don't review kind of like initial analysis, right? But if it's important components of decision-making process. So let's say like we created some sort of analysis on like how a city looks like, and we want to present it to stakeholders to make a decision, like should we invest 10 millions on 20 millions there, then probably makes sense to see that you can actually query your data correctly and not making like very stupid mistakes and like 1 month coming back, yeah, actually return to mess is not that good there, like, and it just burns through like 10 millions. Yeah, not very good, so.
You're not using GitHub pull requests for that, you are just reviewing.
Yeah, for notebooks, no. Yeah, visibility and communication. As we don't have silver bullet for that, like just a few thoughts that we think were helpful for us. Regular updates, post to team and stakeholders. What sort of like what you're working on, what your recent findings. Should do it like at least weekly. Obviously, we already talked about this education inside the organization and expectations management. So like what sort of impact the stakeholders can expect from your model, right? I mean, so like it's like you can create model which solve like all the problem, right? So it's certain accuracy that you can deliver your problem. So if you're kind of forecasting like what will happen in next week, it has confidence intervals, I don't know, like quite wide. And so if your stakeholders see it like, but it's not precise, you say like, yeah, but it's kind of can show you the trend at least. So like really important and like explain people, it's not magic. Fast feedback cycles, if you can, daily, if not, at least weekly, so like you don't get locked inside like your way of thinking, but really like get back the knowledge from your stakeholders. So oversharing is usually not a big issue. If you're afraid like, okay, I'm communicating too much about this, don't be afraid. It's rather like undersharing is usually a problem. And personal notes for scientists, research notes are actually quite good stuff. It's basically when you start writing down like what's the important findings you found during your analysis, and basically when you have to present, you already have kind of the slides ready, so you just can copy paste like to like whatever presentation you have to make to the people. And I think the last one is about storytelling. Storytelling is a good part. It's like art of presenting and explaining the results of your work. And again, no kind of good way of putting like it's good storytelling, but we certainly know like what's bad storytelling. Bad storytelling is like if you're showing the plots, and if you need to spend like 5 minutes explaining what's on the plot, why it matters, what's important, you will lose your stakeholders like right away. They're usually like really busy guys. They work on completely different speed, let's say. So for them, like 1 minute is like eternity. Like at least in Bolt, I mean, people who work there, I mean, they're so fast. I can just like follow them. So if you're explaining 2 minutes, you already lost them. So it's very important to visualize your things in a good way, and very important to know your audience. So one graph that you can show to people who are familiar with data science, and a completely different graph that you probably would go and show your CFO. So you might say like, but okay, it's not my job actually, they should learn the stuff. No, it's actually part of our job as data scientists to actually cater the audience accordingly. And one example here from our recent work, for example, there are good and bad things about this plot. Like the bad things, obviously, there's no axis, no legend, not anything. So I had to remove this sensitive data. But I think what's good, what I really like about it, okay, it's Scatterplot, but it's organized in that way that it's basically can work as a histogram. What's probably missing is like if you add like make those points transparent, then you'll see like where your data is clustered more, so you kind of get like the density feeling of the data, as well as kind of what's your underlying median or average trend for your data. So you can get a lot of information out of this data or out of this plot, but probably it's not something you will go and show it to your CEO. So it's like a bit more involved. So to conclude, as you probably already seen from thing I mentioned, data science Bolt is all about like making an impact to business. That's like kind of our mantra that we keep repeating, like how to make an impact, how to make an impact. Our work is much more than machine learning. It's basically machine learning is a very small part of it, important part, but really still only really, really small part. If, for example, linear regression, like very simple linear regression model, like will do the trick. If it's much faster to arrive at that model and put it in live and start like making money for us, so we'll go for there. I mean, we can train like all the fancy models later. So like, let's start first, create fast baseline, start putting things live. Finding a place for the team in the org, as well as like teaching organization on how to operate with the team. So how to place the task for data science, how to receive tasks for them, like how to make your data science function really efficient one, because you're probably spending a lot of money on those people because they require like data analysts, they require supporting data engineers. So it's like very expensive function. So if you're not spending it wisely, you're just pouring through the money. That doesn't make much sense. And obviously how to make team work together in the most efficient way, how to solve like this visibility and communication struggles. Really important. Anyway, thank you for your attention. I think we still have some time for questions, so please go ahead. All the questions were asked. Nice.
How it happened that your picture is on the wall?
I think, I don't know. It looks like Moby though for me. Good one.
There is questions?
Could you probably bring an example of how you sell the idea of what you've achieved to the business people? So is it kind of elevator speech or?
You mean how to sell an idea?
Yeah, because you mentioned that selling the idea to the engineering and data scientists is different from the selling the idea to the business people. So how different is that? So maybe you have some kind of example that You just show the plain graph where there is just a linear graph, and you say, when we reach here, we get the $200 million more. And it's a...
Yeah, pretty much. As you know, as they say, like, in God we trust, all others bring data. So it's exactly true for us. So if you want to sell the idea, we have to bring the data, and this data better be good. So like the data or visualization or the analysis conclusion that you bring to your stakeholders actually have to hold. So like we have like very sharp guys who will like look at all the small things on the plot, and they'll start asking, okay, I'm investing here, but the plot actually going down, but everywhere else is going up. So what's going on? So you better kind of like know every single detail about how those things work.
So when you promote that, you're making yourself responsible for that investment, right?
Absolutely.
So yeah, you have to be like 100% sure before you promote that.
Yeah, obviously, because otherwise, like, why are you doing this, right? I mean, like, so it's like if you just want to draw random plots, it's like nothing. But it's actually making.
What about the probability theory? If you're kind of 95% sure, so you don't promote that, right?
100% sure is like kind of. Say you're very sure, right? I mean, and obviously when we present our things, our finding is usually like we have tons of disclaimers. This was learned from the 2 cities in the last 6 months. So we assume like this things might change in the future. We don't know underlying dynamics of like competition and everything, but we're still quite sure that might be create some sort of impact. So all the disclaimers for sure, but basically you should gather enough data, enough evidence to support your hypothesis that you actually can go and present to people saying, I think now as a data science, and I have a lot of evidence that if we do this, it actually leads to this. And obviously we A/B test, so like nobody will kill you if you kind of present something, it doesn't work in reality. So we can obviously we start with small rollout tests, so like impact on a small number of users, then we see how things go. Obviously our markets are very different. We're in like more than 30 countries. So like in some market the idea might work, in other market might not work. They're also very important like to test like very broadly.
So my question was, do you first make disclaimer and then sell the idea? Or you don't sell the idea if you have a reason to make the disclaimer?
It depends on disclaimer. I mean,
okay.
Yeah, because if disclaimer is like really strong that you don't like sure that you should sell the idea, probably you have to gather more data. Disclaimers just has to be there, like the people understand, like there are things that like outside of control, and we have thought about that. So it's usually kind of trade-off. So we made this disclaimer. What we can do, we can kind of get rid of this disclaimer. So either by gathering more data, doing surveys, like analyzing things more, or we can move fast. Try it out in live and see what happens. And we kind of service, and in the end, that's already like business decisions, right? For us, it's like just to present all the opportunities, say like, okay, that's high risk, high reward. If we spend more time, like less risk, like less reward probably, like make a decision. But we have to provide everything.
How often do you actually work with projects that they don't work out? And what do you do then? How do you explain this?
Usually we go like in the back room and cry.
I mean, I do the same.
Yeah. It happens often, obviously. I think I read like that Spotify claimed that about 95% of the A/B tests come out like non-significant results. We have seen very similar results in our work, let's say. So it's completely fine that your project not delivering kind of. Let's say your model works, it's like quite accurate, but then you're starting impacting people with the smaller and see like people are behaving completely different. And then you have like to come back to the drawing board, like were my assumptions wrong, were my model wrong, or the people wrong, or like, so that's why I think it's very impossible, like very, very important during the project when you work to start delivering value right ahead. So like basically you start with exploratory data analysis and you should share these results with the shareholders, because by that you're already creating a value for them, like understanding city as well. So that's already like half of the thing that you can get out there for them. So even if you're not succeeded at kind of solving that task, we created like more data around like what actually happens with our cities. So I think it's always kind of we can achieve at least something. So we're not crying that much in the back door.
Thanks. You mentioned that you have data analysts, data scientists, engineers in your team. So where are the boundaries between them? So between their
boundaries.
responsibilities. Yeah.
Good question. So sometimes those boundaries are a bit blurred. So like our analysts also like build models. Data engineers really, I think like there's like bigger boundary maybe between data engineers and data scientists. So data engineers work mostly with system and code and less with kind of models. So they kind of deliver this data and capability for us. Between data analysts and data scientists, I think data analysts in our case are mostly geared towards kind of delivering this automated way of exploring the knowledge that we have for all the stakeholders, kind of building like all those automated reports, best way of visualizing data. So like creating this data awareness in the team. As well as for data scientists, mostly like we are geared towards creating like automated way of influencing our world, basically. So kind of we're getting like the data from the world, then we're making some sort of sophisticated decision with the help of, I don't know, machine learning operations, research, what's not, and then we're like feeding back. So it's more like kind of like automating decision making, or for analyst case, like automating, like helping to create like awareness for the decision makers, human decision makers.
You've mentioned that your data science team often pitches ideas to project managers and people. So it's not only like research department, but also like a place where new features are generated.
Yes. Yeah.
So I was wondering if it is some sort of structured process where you have like meetings specifically to pitch new ideas, or just something comes up and then you go straight to the project manager and describe?
It can happen basically in the kitchen, drinking coffee, talking with Marcus. Oh, Marcus, that's a great idea, and then boom, like next week already, like start working on this. So it's basically it's as a creativity, you cannot guide it. It's basically if it happens, it happens. So we don't have kind of like the set meetings. Like every Monday at 9 a.m. we are creative and sharing the ideas. So it's mostly, yes, exactly. It can happen during the brainstorm, during like sessions where we discuss something else. It can happen during the morning coffee. It can happen on other events.
I just imagined that like your data science team like probably gets a lot of research tasks anyway. So like do you come up with like potential innovations while solving these research tasks?
Sometimes yes. We also have a really cool initiative inside the team which we call data hacks. It's basically small forms of hackathons. So each week, 2 people of our team work on one task that they will pick up, like random task, like whatever they want to deal with. Whether like, okay, let's try new network architecture we read in the paper, or let's solve this business problem. So like 2 people just working for one straight day, one particular task. So your creativity burst can happen there.
So you actually do have days when you are trying to be creative, right?
We are trying. Some days it's better than others. Some days it's like, yeah, okay, more research needed.
Okay, thanks.
Hi, thank you all for presentation. It was very interesting. Actually, I have a question. You mentioned that first it was 3 people in your team, and now you have 30. So how does management changed in the team to lead such a big team?
I think a lot of change happened, or like not happened, but started gradually happening by hiring, like very important part of like hiring like the first people who will start building your team, and then giving the people like independence and kind of guiding the first joiners on like what do you want to achieve as your team, and then those people will start kind of not managing but kind of spreading the idea, like the essence of your team like around. So we're focusing a lot of like independency of our researchers. So like people are not dependent on everybody; they can solve the task themselves. But at some point, obviously, you have to bring additional management power on top, because like just communication overhead will become like much more. And then it's basically you just have to kind of find the correct, like not the correct, but kind of the moment where it probably makes sense to kind of start taking like some dedicated team. You see like some sort of set of tasks grows like quite big. So you have 3-4 people working on this. Probably like makes sense to kind of find the people who will lead them, like in a sense, like start managing like overhead and like expectations, everything. So And if you have like people, like even like either inside your team or you can bring somebody outside, probably that's the right spot. But again, it's like there's like no rules that's the point where you should do it. So it's like kind of feeling of like, do you have enough people working on the same kind of problem? Is this problem is like important enough to like still continue to solve this and just follow from there? As well as I said, like in terms of those set of people who have data engineers, who have data science and data analysts, so that they're already kind of clustered, like through the distinctive cluster. But inside like those teams, for example, in data science, we currently have kind of set up of say 4 kind of leads. So we have like one head lead who kind of manages whole team, and then we have 3 say field leads who like lead certain part of the like discoveries that we do. So it's we try to solve it like that.
Thank you.
You're welcome.
Any more questions?
A bit provocative but short question. How would you estimate the impact of your efforts, the efforts of yourself and your team on the business?
I was hoping nobody will ask tricky questions today.
Sorry for
yeah.
that. We can forget about it.
No. For some things, it's very straightforward, right? I mean, like if you're impacting some sort of thing where you're generating money, right? Then you can do a kind of A/B test setup, and then you at least like know more or less like whether like the thing that you deployed, how much uplift you get in terms of, I don't know, income, right? Then you basically can say, okay, we are saving the company 5% of budget, I don't know which months. That's quite easy. For the things that are a bit more under the hood, say like prediction of estimated time of arrival, right? I mean, so like we are making more precise predictions. Like say we make like 2 seconds more precise predictions. How much does it cost? I mean, very not trivial. So for some things, it's just like, you know that they have to be improved and like you work on this and just like. But you have to sell that. Yes, you have to sell that. So it's basically, if you start selling this and like people like with decision, like make decisions say like it's not important, then you, again, as we talk, we have to get the data. You start showing like, so you see like all those calls to customer support that we get because of that. If we improve this, let's say like we can decrease this amount of like by 10%, or let's say like people are not getting cars because of that, because our estimation is wrong and they're not coming back. So again, like you have to find more data to back up like kind of the thing that you're claiming, whether it's like kind of an impact or whatever else.
Is there any kind of best practice that you have to convert any kind of this argument of the pro or contra to the money, to the equivalent of the money when talking to business? So when you speak that the customer is not getting their cars or they're getting their cars faster than before, you have to convert that into money. That we will save that this kind of this amount of money if we apply this change because of our investigation, our research. So do you always convert everything into money when talking to business, or you just try to involve the business people into understanding what's behind the numbers we show them?
Yeah, the second one, obviously. And we are quite lucky in that terms that we don't have to prove anything with money. I would say that would be like a bit wrong. It's like saying like people not getting some essence of some things, because what we actually want to achieve, we want like to make life better both for our riders and drivers, right? Like for people to get the car weight they want, and for people who are driving on the car actually earn as much as they can, right? I mean, so that's our end goal. So we can't always optimize on like how much more we can get from that, because then it's like very easy to start optimizing for short term. Like next quarter, I want to maximize my revenue. What will I do? I will raise my prices, right? I mean, like in the quarter after that, I will like plummet. So like say like if like we're here for the long game, and as far as we know from stakeholders, for owners of the company, we are here for the long game. We always have to like optimize for also like good perception of our product and like for goodness of our product, both for riders and drivers. So we're like really lucky that our decision makers are getting that, and that's fine with them.
So thank you for your questions. Let's keep shadow. And thank you, Maksim, for very interesting information. It was really pleasant to hear. And a small present for you.
Ooh, in this. Thank you.
Thank you.